Welcome to All This Math. This is Professor Parker. Today, I feel like recognizing Assata Shakur. You see, I got my Assata is Welcome Here sweatshirt on. Assata Shakur, one-time Black Panther Party for Self-Defense member. Also, we work closely with the Free Breakfast Program early in the morning in Harlem. And one-time Black Liberation Army member. Also, she wrote an excellent autobiography called Assata that I recommend to everybody. And she definitely has influenced me with her political writing and her political work throughout her lifetime. And I just want to take time to recognize her. So shout out to Assata Shakur. All right. Also, if you have not yet subscribed to the YouTube channel, please go ahead and subscribe to the channel. Also, turn on post notifications and share these videos. Let people know we're doing All This Math. You know, how you get a little brief history lesson and also a math lesson at the same time. All right. So let's look at what we're getting into today. Today we're going to solve an equation. A lot of people will look at this equation, get intimidated right away. You know why? Because of the fractions. People don't like fractions. I get it. A lot of people weren't really effectively taught what a fraction is, how to manipulate fractions, how to add them, subtract them, divide them, and multiply them. Fractions seem intimidating. Cool. I got something for that. I'm going to show you how to clear out all the fractions in this equation. All right. But in order to do that, the trick is you got to know a little bit about fractions. You have to know how to find the least common denominator, also known as LCD, of two fractions, two or more fractions, in order to do this. So we don't like fractions. Okay, cool. We'll work more efficiently and we'll get rid of the fractions. First thing you want to do, look at the whole equation. Look at what it says. 4/3 plus 2/3 x is equal to 31/15 plus 8/5 x plus 1/5. We're trying to solve for x. So we want to know what number can I replace x with that will make this a true statement, that will make the left side of this equal to the right side, because we want to have everything add up. Math is all about finding the truth. That's what math is about. Math is about finding the truth, finding what value of x is going to make this balanced, right? We're trying to find balance, all right? Just like in our lives, we want to find balance. Okay, so we want to get rid of the fractions, though. First thing you do, look at all your denominators. The denominators, of course, are the bottom number in the fraction. 4/3, denominator's 3. Over here, we got a 3, we got a 15, a 5, and a 5. Look at all your denominators. What would the LCD be if I was just adding up all them fractions or subtracting them fractions from each other? The LCD would be 15, right? Now, I'm not going to take a lot of time on this particular problem in this particular video to go into like how to find an LCD. I have another video on the channel that shows how to find LCDs and how to add and subtract fractions. I probably have actually multiple videos on the channel to show how to do that, right? So 15 is the LCD because 15 is the lowest number that they all have in common, right? That they all can multiply into evenly. 3 times 5 gives me 15. 15 times 1 gives me 15. 5 times 3 gives me 15. So all three of these numbers, right? Because the 3 repeats and the 5 repeats, it's really only 3 numbers, can multiply into 15. So therefore, I'm going to take that number and I'm going to multiply every single one of these 5 terms by 15. So step 1 is figure out what the LCD would be of all of those terms and then multiply each term by the LCD. So what I do is I draw a bracket around the whole equation like this, and I write that number. In this case, it's 15. Write it outside like that, right? So then I'm going to do 15 times 4/3, right? Now, the way I would do that is I would do 15 times 4, which is 60, and then 60 over 3 is 60 divided by 3. 60 divided by 3 is 20. So that means 15 times 4/3 is 20. So that 4/3 turned into a 20. Fraction is gone. See what just happened? So for those of y'all that don't like fractions, cool. Let's get rid of them. Let's get rid of them. Ain't no big thing. If you don't like it, get rid of it. All right? Now, we do 15 times 2/3 x. 15 times 2 is 30. 30 over 3 is 30 divided by 3. 30 divided by 3 is 10. So that's 10x. So I got plus 10x. Then I'm going to do the same thing with 15 times 31 over 15. Now, I'm going to do this one a little differently because if I multiply 15 times 31, that number's kind of husky, right? Another way I could do this, I could do 15 divided by the denominator. And then I can multiply that quotient by the numerator. So 15 divided by 15 is going to be 1. And then 1 times 31 is just 31. So I had 3 fractions that are all gone now. Do the same thing here. 15 divided by 5, I'm going to get 3. 3 times 8 is 24. So that's 24x. 15 divided by 5 is 3. 3 times 1 is 3. But peep this, though. You notice how I divided by the denominator and then multiplied that by the numerator? I got 3. I could have also did 15 times 1 and got 15 and divided by 5. I still get 3. So either way you do it, you'll still get the result, the product of 15 and 1/5, right? That's why I'm able to do that, because we get the same result. Now, all the fractions are gone. So now we got to employ our steps and our different techniques for solving equations. This is called a multi-step equation, because we gotta do more than one step to solve it. That's why it's called a multi-step equation, right? One of our issues is we got x's in too many places. I got a 24x right here and I got a 10x right here. I'm trying to solve for x, so I need to solve for x by getting x by itself in one place, right? But before I do that, and let me say this too. There is no one single correct way to finish this problem. So if you think that there's one single correct way to finish this problem, get that out your head right now, right? 20 different students could probably do this problem 20 different ways, and they could all be correct as long as they follow mathematical rules, right? In terms of order, right? Now, what I'm going to do next is I'm going to combine the 31 and the 3, right? Because I can do that, because I can combine like terms, right? But I don't have to do that. I could have subtracted 24x on both sides. I could have did that, and that's still correct. So make sure you disabuse yourself of this notion that there's only one correct way to solve a problem in mathematics or in algebra or in mathematics in general. All right? There are multiple ways. So what's 31 plus 3? 31 plus 3 is 34. So now, next step, it looks like this. 20 plus 10x is equal to 34 plus 24x. All right? You see how the problem's getting smaller and smaller? It started out like this with all these fractions. Then the fractions were going. Now we have 5 terms. Now we got 4 terms. All right? So now what I'm going to do is, since I want to get x by itself, and I got x's in 2 different places, I'm going to get rid of this 24x. Now, how am I going to get rid of the 24x? I'm going to do the opposite operation. When we're solving equations, when we want to get rid of a term or an expression within an equation, we do the opposite operation from what that term or expression is involved in. What does that mean? What is this 24x doing? Always ask yourself that. That thing I'm trying to get rid of, what is it doing right now when I look on the paper or I look on the board? It's being added. So then you say, okay, well, if I want to get rid of it, I got to do the opposite of addition. The opposite of addition is subtraction. So we're going to do minus 24x, boom. But if I do it on the right side of the equation, I also have to be balanced, because remember, math is all about balance. Math is all about balance. What we do on the right side, we also do on the left side. I'm not going to subtract it from the 20 because those aren't like terms. I'm going to subtract it from the 10x because those are like terms. Like terms have the same variable with the same exponent. This has an x, this has an x. 20 don't got no x. So you can't subtract 24x from 20. 20 don't got no x, right? Now, if we were multiplying or dividing, that's a different story. It's a different set of rules. But if we add and subtracting, we can only combine what we call like terms, right? X's go with x's. Constants go with constants. 34 is a constant. 20 is a constant. A constant is just a number, right? A number by itself, all right? So over here, I go minus 24x. Boom, boom. Bring the 20 down. Now, what's 10 minus 24? I got to know how to add and subtract positive and negative numbers. That's mandatory. I got to know how to do that. When I do 10 minus 24, I picture a number line in my head. I start at 10, and since I'm subtracting, I go 24 spaces to the left. If I visualize that, I started at 10, I went 24 spaces to the left, I'm going to pass 0, I'm going over to the negative side, I end up at negative 14. So this is minus 14x. Negative 14x minus 14x are the same thing. Then I bring the equal sign down. Then I bring the 34 down. This is gone because positive 24x minus 24x is nothing. It's 0. It's gone. All right. Now, the problem getting smaller and smaller. Now I only got 3 terms. Now my goal is to get x by itself. So dig it. I need to get rid of 2 things. This 20 and this negative 14. This 20 and this negative 14. And then x will be by itself on the left side of the equal sign. I'm going to get rid of the 20 first because that's a little further away, right? So this is a positive 20, right? This 20 is not being subtracted. That minus sign goes with the 14x. Positive 20 is just positive 20, right? But what's the opposite of a positive 20? A negative 20, right? So the opposite would be to subtract 20. And then on the right side, subtract 20. That's going to cancel out, right? The negative 14x is going to come down. The equal sign comes down. And again, I got to know how to do subtraction. 34 take away 20 is 14. I'm getting closer to my result. Now I'm trying to get x by itself. Now I got to get rid of this negative 14. This negative 14 is not being subtracted. Think about what it's doing with the x. It's being multiplied by the x. So I got to think to myself, what's the opposite of multiplication? Division. So I divide by the same exact number. Divide by negative 14. Divide by negative 14. Boom, boom. X equals negative 1. X equal to negative 1. Now, I think that's the answer. I'm very positive that's the answer. Matter of fact, I already know that's the answer. But what I want y'all to do is get into the habit of always checking your work. Whenever you solve equations, always check your work. Checking your work is really about empowerment. It's about not having to wait for a teacher to validate you and tell you your answer's right. You can tell yourself the answer's right. Go check your work, right? So if I do that, hopefully I have enough space. All right, I go back to the original equation. Right? Put this symbol right here. This is my symbol for check, right? I rewrite the equation except I replace the x's with my solution, negative 1, or my proposed solution. So I got 4/3 plus 2/3 times negative 1 is equal to 31/15 plus 8/5 times negative 1 plus 1/5. Because remember, math is all about finding the truth, right? It's all about finding the truth. Now, the question is this a true statement? Does the left side equal the right side? Does everything add up? So first, order of operations on the left side, I'm going to multiply first. So then I got 4/3 minus 2/3. Because 2/3 times negative 1 is negative 2/3. Right side, I'm going to do this multiplication right here. 31/15 minus 8/5 plus 1/5, right? So to the left side, I got 4/3 minus 2/3. I got common denominators already. So I can just go ahead and subtract that. That's going to be 2/3. Now I want to see if everything on the right side is equal to 2/3, because if it is, then that's proof that my answer is right. Right? Now, this negative 8/5 and this 1/5, I can combine those because they already have the same denominator. They got common denominators already. And we can't add or subtract fractions unless they have common denominators. We got to have common denominators. And 8/5 and 1/5 do, or negative 8/5 and 1/5 do. So I bring down the 31/15. Negative 8 plus 1 is negative 7. That's minus 7/5. Now my question is, does this equal 2/3? When I first look at it, it looked like it don't. But watch what's going to happen when I get common denominators on the right side. The common denominator of 15 and 5 is 15, just like it was up here. So, but when I change this 5 to a 15, see that denominator changes to a 15. That 5 changed to a 15. That 5 changed to a 15. Think to yourself, what do I multiply by 5 to make it a 15? A 3, because 5 times 3 is 15. I also got to multiply 7 times 3. 7 times 3 is 21. So I got 31/15 minus 21/15. 31/15 minus 21/15. On the left side, I got 2/3. So 2/3 is equal to 31 minus 21 is 10. That's 10/15. Now the question is 2/3 equal to 10/15? It is. Because if I reduce this fraction by dividing each of the numbers by 5, 10 divided by 5 is 2. 15 divided by 5 is 3. So 2/3 is equal to 2/3. So that's proof that this is right. And you always want to check your work. Always check your work just to make sure. Right? And if it don't add up, and if it don't check out, that means more than likely you made a mistake in here. And then the job for you is to go back and find your mistake. Find your error. Find what you did wrong. All right? So again, if you haven't subscribed to the channel yet, go ahead and subscribe to the channel. Also, don't be selfish with these videos. Share the videos. Send them to somebody. It's easy now. Everybody got a smartphone now, right? Just hit send. Just copy the link. Go ahead, copy the link and send it to somebody. All right? So, as always, well, before I get into that, now it's not enough to just know how to do this problem or have watched this video. Now you got to go practice. You have to go practice, right? You got to go practice. I can show you how to do it, but you actually learn it from practicing on your own. All right? So make sure you go practice on your own, and always remember that there's all this math all around you. Peace.